Now let's talk about how to make arithmetic and linear algebra operations, and also how to generate different values. Even though you already know how to generate sequences, I'll show you a couple of new things. And I'm going to use the script. I will just continue, and in this case I will make a new section for every part of our learning sequence. So in this case I make a new section which I called let's say manipulate arithmetic or calculations and data manipulations. Okay, so we'll start with a simple thing, how to generate values. And you already know that you can generate values by using a colon, right? So for example, if you write a equal to 1 colon 5, and then display a, you can generate a sequence between 1 and 5. By the way, I forgot to tell you about this in the previous video. When you work with section, it's very easy to run the section without actually using a mouse. Just use Ctrl-Enter in Windows or Command-Enter in Mac. So Command-Enter runs the current section. Okay. So, but sometimes you don't know this step. For example, you would like to have an interval between 0 and 1, and you would like to split this interval into 12 or 20 equal portions. Of course, you can calculate this step, but let MATLAB do that. So we just say, for example, x equal to linspace. It means linearly splitted space. And then you specify several things. First of all, you specify the beginning and the end of the interval. And then you specify a number n, which is actually, if you want to split your interval into, for example, 5 equal portions, n should be by 1 larger than this number. For example, if we say 6, we will split our interval into 5 equal portions. So let me show you that. So you can see that we have, that's the first subinterval between 0 and 0.2. Then that's the second, 0.2, 0.4. Then we have the third, the fourth, and the fifth. So we have exactly 5 subintervals. But of course, we need 6 numbers to generate the 5 subintervals. Therefore, that's the number 6. So that's how many numbers we have. Okay. You can also generate vectors and numbers with a certain value inside. For example, if you use a function zeros, let's say 1 and 5, it generates a vector, or in this case it's a matrix, but it will look as a vector with 1 row and 5 columns, and it will fill this vector with zeros. Okay, so I'll show you that. So you can see we have 5 zeros. Okay, the same if you use ones, 1, 5. So you will have, I need to display it. So you can see that we have 5 ones, or you can specify the dimension you would like, for example, ones, 4 rows and 6 columns, for example, right? And then display x, so you can see 4 row and 5 columns. Okay. So that's how to generate values. And now let's talk about how to make different manipulations with generated values. First of all, how to repeat the generated values, for example, several times, and then how to change the dimension of the values. So let me show you a couple of examples. You can repeat any vector, any matrix in MATLAB, and make a new matrix and new vector which will consist of copies of the first one. Okay, let me show you something. For example, I generate a vector 1 to 5. So I'll just show you disp x. So that's easy. We have a vector 1 to 5, right? Now, what I'm going to do, I say repmat, which means replicate a matrix. Replicate a matrix. Then I need to write how many rows, how many columns I would like to replicate this matrix, this vector to. For example, I say 2 and 2, so 2 rows and 2 columns. Now I will make a matrix with 2 rows and 2 columns, and every cell of this matrix will consist of this vector. So look, so that's the first 1, 2, 3, 4, 5. That's the second 1, 2, 3, 4, 5. Then we have the second row, first column, and the second column and second row. Okay. Then you can see the dimension of the x is actually 2 rows and 10 columns, because we have 1, 2, 3, 4, 5 in each. Okay. And then of course you can do the same for any matrices. For example, we can say repmat, and then we can make a matrix 1, 2, semicolon 3, 4. Okay, I'll start with a simple thing. I will not replicate anything actually. I will just show you the original matrix. You see 1, 2, 3, 4. Then you can say replicate it, for example, make 3 rows and 3 columns. So I have 2 rows and 2 columns in original matrix, and then I will replicate it 3 times in horizontal direction and 3 times in vertical direction. So I will have a matrix 6 by 6. So you can see that's the first, then we have the second, the third, first, second, third. So we have a dimension 6 by 6. Okay. Another thing you can do is to reshape your matrix, meaning you can change the number of rows and number of columns. Again, let me generate a vector first and display it. So you can see we have a vector from 1 to 12. Now I will display a reshaped version of this vector. So I use function reshape, the vector x. Then I need to say how many rows and how many columns I would like to have. And of course, the number of elements in the result should be the same as the number of elements in the original data. For example, I have 12, so I can make, for example, a matrix 2 by 6, 2 rows and 6 columns. And now you can see indeed we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. I can make it like 4, 2 or 4, 3, sorry. 4 rows and 3 columns. So you can see that's the first column, the second column, and the third column. And when we use function reshape, it always reshapes the values column-wise. So it takes all values for the first column, then it takes all values for the second column, and so on. Okay. So that's another thing. And the next thing I would like to show is how to sort your values. And in this case, I will use our height and weight values generated in the first sequence. So I'll show you, for example, the weight values first. So this is the weight values. Okay. And you can see that the order of the weight values is the values are not ordered. So we have the smallest values is second, it's not first. And then we have the next smallest, this one, and then we have the next smallest, this one, and so on. Okay. You can actually order the values. Let me make a new variable. WOR means W order it. If you use function sort. Okay. Function sort simply orders or sorts the values in from the smallest to the largest. Okay, so you can see now we have the smallest here, then the next, the next, the next, and so on. If you want, you can also show in opposite direction. Then you just need to say descend. Okay, so now you can see it's the direction is opposite. So we have the largest number first, and the next. Okay. What else? When you sort the values, you sort values only in this vector, but you remember we have another 2 vectors, vector with names and vector with height values. Okay, can we sort, for example, height values and names accordingly? So we have a name of the heaviest person first, then the name of the next heaviest person, then the name of the next heaviest person, and so on. Yeah, we can do that. Function sort actually can return 2 things. First, it's sorted values, and second, it's indices of sorted values. Let me show you how it works. So now I'm going to do the following. I say W order it, and then I also say I, and then sort W. Okay. Let me show you both. W order it first, and then I. Okay. So you can see that the W order it is the same as we had before. It's just order it values. But this vector I, it tells me a position of every value in the original vector. For example, 80 was number 1, and 60 was number 2, and 70 was a value number 3. So we have the original positions of the values. And then we can use these original positions to show, to resort some other vectors. For example, we can resort the names. So names order it. It's our names, and then I will use this I. So it means that first of all it will take the second name and make it first. Then it will take the third name, make it second, the first name, make it third, and then the fourth name. Okay. Then if we show it, display NO, so you can see that the order is different. In order to, if you want to see it better, I'll show you all the values. So first of all, I will show the original values, names and the weight, and then I will show you the ordered values, disp WO and disp NO. Now you can see that that's the original values. We have 80 kilograms, it's Lena, 60 kilograms N, 70 kilograms pair, and then 90 kilograms Lars. Okay. Now look, we have in other order, but still 60 is N, you can see. and 70 is pair, and then 80 is linear, and 90 is Lars. So we didn't change this link between the names and the weight. We just changed the order. And that's how we did it. We ordered values, we got the indices of ordered values, and then we use indices to reorder the names in this case.